This is going to be about solving a distance, rate, time problem using a linear equation. So distance, rate, and time are all related by the equation d equals rt. Now that just means that when you multiply the rate times the time, you get the total distance. And it makes sense because your rate is how fast you're going, right? So let's say you can run a mile in 10 minutes, and then your time is how long you're doing it, right? So how fast you're going and how long you're going for determines your total distance, how far you go. So if you can run a 10-minute mile and you're running for 30 minutes, then you're going to end up going 3 miles. So let's look at this question. Diane drove to the mountains last weekend. There was heavy traffic on the way there, and the trip took 8 hours. So let's draw this out. Diane drove to the mountains. So here are the mountains. Beautiful. And then here's Diane over here in her car driving there. Nice green buggy. All right, so she's driving to the mountains on this long forsaken road. All right, so Diane drove to the mountains and there was heavy traffic, so it took 8 hours on the way there, right? Now, I don't know exactly how far away the mountains are, but one thing I do know is however far away they are from her house, they're going to be the same distance back, right? As long as she's not taking a different route. So we're assuming that she's taking the same route here. All right, there was heavy traffic on the way there and it took 8 hours. When she drove home, there was no traffic and it only took 5 hours. So going back this way, it only took 5 hours. And again, we're assuming that it was an even amount of distance. So this distance there was equal to the distance back. If her average rate was 21 miles per hour faster on the trip home, how far does Diane live from the mountains? Don't do any rounding. So what we're going to do is we're going to use this rate times time and make these equal to each other since the distance is equal, right? If the distance is equal, then we could also say that the rate and the times are equal. Let's go ahead and show this in another color. So let's say her way back was in blue. If that distance is also equal to the rate times time, and if the distances are equal to each other, then we could just say that the rate times time for the way back is equal to the rate times time for the way there, right? This rate times time is equal to this rate times time since the distances are equal to each other. So let's go ahead and figure out what our rate and what our time was. Well, we want to solve for x. X, we know how many hours it took, but we don't know how many miles it was, right? So that's what our x is going to be. Our x is going to be our miles. So let's go ahead. I'm going to erase my picture and I'm going to write this as an equation. I'm just going to clear the whole screen. I think it'll be easier. All right, so let's think about what's my distance. What's my rate? Well, the trip took me 8 hours, and I'm not sure exactly how fast we were going, but I know that we're going and trying to figure out x, right? So 8x is equal to, on the way back, it took only 5 hours, right? And her average rate was 21 miles per hour faster on the trip home. So if it only took 5 hours, and she was going 21 miles faster, faster than what? Faster than the first value, faster than x. So this is represented as x plus 21 because it's 21 miles per hour faster. And that makes sense, right? Because if it only took 5 hours, then you're obviously going faster than when it took 8 hours. So make sure if you're adding, it's going with the smaller number of hours. If you're subtracting, it would be going with the greater number of hours. So 8x equals, and whenever we have a variable in the parentheses, since we can't add these together, what we do is we distribute 5 times x and 5 times 21, which would give us 5x. Let's see, 5 times 20 is 100, and 5 times 1 is 5. So that would be 105. All right, in order to solve for x, we need to get all the x's on one side. So let's subtract 5x from both sides. And we'll get 3x equals 105. And if you don't get a whole number, you might want to check your answer once you're done dividing, because usually it'll give you something that's easier to work with. So if you do 3 divided by 3, that cancels out, which means that x equals 105 divided by 3, which is 35. Right? 3 times 30 is 90, and then 3 times 5 is 15. 90 plus 15 makes 105. So let's interpret what this means. If x is 35, then that doesn't tell us how far she lives from the mountains. That tells us how fast she was going, right? So since the distance is equal there and back, we could use this and plug it in to either side of the equation, right? Since we should get the same thing. Let's do 35 times 8. Let's see, 8 times 5 would be 40, and 30 times 8 would be 240. So 240 plus 40, that would be 280 miles. Let's try plugging it into the other side and see what we get. 35 plus 21, that would be 6, and 5, 56. What's 56 times 5? Let's see, 56 times 5. 5 times 6 is 30. And 5 times 5 is 25. So that would be 280. Hey, that's what we got on this side. That makes sense because 280 equals 280. So our answer is she lives 280 miles away from the mountains.